I recently discovered that using clever mathematics, you can algorithmically identify the tail of a humpback whale in a photograph. And I'm not saying like just that's a tail, it's a whale. We're talking the individual, whatever that whale's name is, you can identify which specific whale that is. And because tourists like both going everywhere and photographing the whales of tails, you can use that data set of tourist photos to algorithmically follow, track, and analyze the migration patterns of humpback whales. Absolutely amazing. However, to take a closer look at the mass behind this, and maybe find a whale of my own, I'd have to head off to Antarctica. Yep, we're off to Antarctica where we're gonna have a whale at a time.
This video about whales, machine learning, and spreadsheets, get ready, is part of the series I filmed in Antarctica, and this specific video is sponsored by Private Internet Access. They are the VPN that I use because they're 100% open source, and they have a no logs, provably no logs policy. And at the moment, if you use privateinternetaccess.com/standupmaths, it's a mere $2.11 a month once you factor in that you get 3 months for free. And they are the VPN I used while I was in Antarctica filming this video. And for the record, the video is not sponsored by Hurtigruten. I had to give them a lot of money to get myself to Antarctica. And it's not sponsored by Happy Whale. I approached them because I realized they were doing some very interesting mathematics in their pursuit of identifying whales. And spotting and identifying animals is what a trip to Antarctica is all about. And we saw a lot of penguins, possibly too many penguins. Although one day, I saw a penguin fall off an iceberg. Best day of my life. Dolphins, other sea creatures, the works, but there is no bigger animal spotting prize than a whale. We saw a few different types of whales. Sometimes they do an announcement on the ship saying where whales have been spotted. Sometimes you would just be looking at the ocean and a spout of water would suddenly go up and there's a whale there. And like this time, there'll be a commotion and you realize someone else has seen a whale. And I was filming a different bit for a different one of my Antarctica videos. I heard the commotion, I ran over, and there were some humpback whales close-ish. There was one time when a tail went up in the air, but it was a bit too far away. And then another time, I managed to zoom in on my camera. I think it was just close enough. There might just be enough resolution in this image to be able to automatically identify that whale. So I logged into my account on Happy Whale. Yes, we had Wi-Fi in Antarctica. It's ridiculous, I know. I was able to upload the image, not that fast, but still, Antarctica Wi-Fi, and then into the details about what ship I was on, where I saw the whale, the latitude and longitude, as well as which bay. We were on the Antarctic Peninsula on the west side, and that was it. Then I just had to wait while Happy Whale's algorithms crunched away to see if they could recognize what whale owned the tail I had seen.
The important thing is, though, what is the maths we're using to identify these whales?
The people at Happy Whale had to find a way they could automatically identify whales from images of their tails, and so they turned to the website Kaggle. This is owned by Google. It's an online community for analyzing data and machine learning. And so what they did was they started a competition. And there's all sorts of competitions on this. One of my favorites is the Titanic one. This is a data set of most of the people on the Titanic, whether or not they survived the sinking or not. You train some kind of machine learning algorithm on that, and then they give you a test set of data where you get the details about the people, but no information about if they lived or not. And you've got to try and predict it, and people compete to get the best algorithms, and there's all sorts of options on here. In their words, we gave the competitors 5 well-curated catalogs of humpback whale fluke images to develop, train, and test algorithms to achieve the desired automated matching of humpback whale individuals. They actually provided 25,361 training images that had the identity of the whale as part of the dataset, and then there was a test set of 7,960 images with no identification assigned, and so people had to try and work out which whales those 7,960 were. They then submitted what they thought the matches were, didn't have to provide their algorithm yet, and people were ranked by how accurate they were. They then contacted the top 5 ranked entrants to see what their algorithm was and if it could be implemented, and it worked. Here's the grand result. Advanced image recognition, a fully automated, high-accuracy photo identification matching system for humpback whales. And of those top 5 responses, I mean, they ended up using the 3rd ranked one, which was able to correctly identify 97.1% of the unlabeled images. Amazing. But of all top 5, 4 of them all used densely connected convolutional networks. So we'll go into that in more detail. The one that didn't use a convolutional network used other methods that actually needed at least an order of magnitude more processing power to achieve the same result. So this is clearly the way to go. But what is a densely connected convolutional network? Well, densely connected just means lots of connections, so we're going to ignore that. The network part is a neural network, and that has been explained far better than I can. I'm not going to use this video to explain what a neural network is because 3 Blue 1 Brown has already done that perfectly, and they use as their example image processing. Here is an image of a handwritten 9 in this case, and then they show how you can take that handwritten image, each pixel becomes a single node, and then it goes into this, a neural network. So every single node at the beginning here is 1 pixel from the image, and then you've got these links, and each one's weighted, and what the value is in each of these determines what the combined value is in these based on the weighted links, which control these 10 end ones. And there's 10 of them because 1 corresponds to each digit from 0 to 9, and whichever one lights up with the biggest value is the digit the neural network thinks the original hand-drawn symbol was. And it works! Neural networks are absolutely amazing. And 3 Blue 1 Brown, I mean, Grant just knocked it out of the park with these videos, so I highly recommend you go and check them out. However, what I thought I would give an extra explanation on is this word convolutional, and Grant briefly mentions this as a type of network in their videos, but this is a particular type of neural network that's very good at working on images. And the issue is, images have too many pixels. For example, if we take my picture of a whale tail, open it in Photoshop, crop it down to one just small low resolution version, that's still 93 pixels by 60 pixels. And if we grayscale that, we've now got 5,580 different values which are going into our neural network. And this is a tiny image. Big images are going to have way more pixels going in. That's too many nodes in our neural network. We need to simplify that down somehow. Against my better judgment, I'm going to try and make a convolutional layer for machine learning, analyzing an image in Excel, which I am already regretting. So what I've done so far is I've pasted in all our values. So every single cell is one of those pixels, and they're all different values between 0 and 1. And actually, I've inverted them so that white cells are 0 and black cells are 1. I'm now going to select the entire image, and I'm going to use conditional formatting. So if I go into conditional formatting here, I'm going to use a classic spectrum with the lowest value. So the background is going to be white, and then the maximum values of the foreground are going to be black. And in theory, this should give us it's loading a bit. Okay, Excel very much not designed for. There it is. Okay, not designed for this. It's taken a while, but you can see there's the whale tail appearing. And actually, I'm going to zoom out a little so we can see it all. Look at that. So that is my original image of the whale tail. It's just values in a spreadsheet. But, as we established, too many values. Imagine an even bigger picture. We couldn't put all of these into a neural network, too many nodes. So we're going to get a filter, often called a kernel, which is much, much smaller. I'm going to do a little 4x4 one up here in the corner. Okay, so I filled this in. It's 8 negative ones, 8 positive ones. You take this 4x4 grid and you apply it to every possible 4x4 grid in here. So you apply it to this 4x4, you apply it to this 4x4, you apply it to this 4x4. When I say apply it, I mean you multiply all the matching squares by the matching values, and then you add them all up. So actually, let's try and do that over here. So we'll zoom out and we'll apply that to every single pixel in the image. So we're going to basically copy it over here, but multiplied by this. So that first cell is that one times that one plus that one times that one. Thanks to the magic of editing, here it is now. So I've set all the ones over here to be absolute references, so that stays still on my kernel, the filter. And then these ones here are relative, so they'll move around. And I've used an if-then statement to do basically a rectified linear unit. So if it's below 0, it's 0. If it's above 0, it equals itself. Just it's the way you'll scale things in machine learning. And then that one there is a 0. I can now stretch this out to, I worked it out, it's GL. That would be the same size image again. And there we are. There's our duplicate image. Well, once again, we want to use some conditional formatting so we can see what's going on there. So let's have same thing in again. Background's going to be white. Interesting features are going to be black. It's not 0 to 1 this time, but this will scale. And we see what it looks like. And oh, look at that. Oh, my goodness. So now you can see we've gone from the original image with all sorts of stuff going on to now this. And it's picked out features. It's picked out there's a line here. There's a line there. This is like a line finding algorithm. But because I've coded it up, I can mess around with it a bit. So what if, instead of it being up and down, what if I switched, you know what, let's make the middle all 0. See if that changes anything. Well, that's probably a better line finding algorithm. I could take out... Oh, look at that one. Oh, well, that's just nothing. That doesn't work. Okay, let's put the ones at the bottom again. Yeah, look at that. That's not a bad filter. So now we've lost a lot of the noise and we're just pulling out certain features. So actually, I'm going to switch this half to be all 0s. And then this side... I'm going to put in some more negative 1s. And so what I'm doing now, oh, look at that. That's given us a type of feature. What if these were 1s? Oh, look at that. Oh, I got a lot more noise come. Oh, that's too much. That's too close to the original. That's all the noise back. So this is machine learning by hand. I'm tweaking these knobs to see. Oh, no, that's just a blurry version of the original. Tweaking the knobs manually in this case to see what filter I can use to pull out the features I'm after. And so there, now you can see I'm favoring vertical features. And so, oh, ignore the stripe on, oh, I went too far. This stripe on the side is where we've wrapped off the edge of the image. Let's just clear that. Because we've now got smaller because it's where each 4x4 grid fits. And so here we go. So that I've just messed around. I put some values in. You can see this is now pulling out these vertical and sloped features. And so this convolutional layer means that we can take our original images, instead of taking in every single pixel, we run this kernel over it and we filter it down to just the interesting features. And then only these get passed into the neural network. And of course, we can do this with multiple different filters. And it worked. From the final report, they say, when compared against the workflow of manually matching, the automated workflow, including manual match confirmation, reduced the time required for matching by at least 98%. Isn't that incredible? And they go on to add that it reduced error rates from approximately 6 to 9% down to 1 to 3%, depending on the image quality thresholds. That's including the low quality images, basically. They even say that the error rates go to near 0 for high quality images. Absolutely incredible. It's made a huge impact. I will link to the paper below if you want to go check it out. They've also said that access to the algorithm and the supporting information architecture is available for use at no cost via their website, happywhale.com. So go check that out as well. But it does now raise the question, if they've managed to cut this down over 98% of the manual matching version, what on earth was the manual matching version? How do you do this manually? Thankfully, the ship I was on in Antarctica, the MS Roald Amundsen, was, as well as being a floating luxury hotel, don't get me wrong, was also a science ship. So it had a full-on science lab, all sorts of great science excursions and data collection. I had so much fun. If you go to standupmaths.com/Antarctica, it will take you to the Hurtigruten website that I booked. I mean, I paid for this trip myself. My Patreon supporters will be very pleased to know. But if you want to go on the same trip, I cannot over-recommend it. Please do check that out. And it meant, on board, they had a science coordinator. This is Zoe Walker. And when she was doing science, she had to identify humpback whales the old school way. So I asked her how on earth they did it.
And Zoe, you used to have to look the whales up in a book? So how on earth do you look up a whale in a book?
Well, it's a very, very big book. It's just a very large catalog. So the whale tails, the humpback whales, their tail pattern can be sort of broken down into general categories. So you start based on the amount of whiteness on the tail. So they range, A, B, C, D, from mostly black to mostly white. And then you can see different patterns. So maybe the white is at the stalk or the bottom or the top. And so you start there, and that narrows it down a bit. And then you just spend a lot of time narrowing it down a lot more.
Because I was wondering how on earth you would, because you can't put whales in alphabetical order.
Not so well, no.
But you can do it by like percentage of white. There's a penguin that's just floated by as well. I don't know if that's...
Yeah, that's a penguin. What kind?
I want to say Magellanic.
Correct, ding, 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 ding. Here we have another creature. Please identify this for my continued cooperation.
Oh, that looks like it's going to be a black-browed albatross.
A ding, ding, ding. Someone has been
Look at
engaging
that.
in the science
There it
program.
goes.
Woo.
I feel like I'm bordering on being a biologist. Yeah, okay, so if you want to identify a whale,
Yes.
you look at the percentage of white,
Yes.
you flick through the whale of a book, find that, and then there's just like pictures of tails,
Pretty much.
and you've got to locate the...
Yeah, more or less. So they kind of come in distinct patterns. So if you look at enough whales, you start to see it's not just the percentage of them, but also, more along the bottom or more along the top edge or from the middle going out, or asymmetrical, of course, is everybody's favorite default category.
And then you just spend hours until you find the whale you're after.
You just flick, yeah, you start to become familiar with them, and if they've been seen in that area regularly, then you kind of know where to look. Right. But it's actually very interesting over time because the whale tails evolve as they get new scars and new barnacle marks and maybe boat damage, which is unfortunate, but we do see it. So you might get one that you're like, this is a 90% match, but actually it's something a bit new now.
So the whale has aged.
Yeah.
And, the patina of ocean life. Right, gotcha. Okay, but you'd be pretty happy if you could automate the bulk of that to just take a photo of the tail and it tells you the whale.
I think it's one of the best uses of technology we have.
There you go. An email's just arrived. Let's have a look.
An individual you encountered in Antarctica was determined to be new to science, to the best of our knowledge, and has been assigned an official well number. We hope you're pretty excited.
I'm pretty excited.
The problem...
Sorry.
Do you want to...
I'll take it from here. The problem is, a few days later, I got another email, and it turns out they weren't able to match it to a different whale in the database, giving it the new catchy name, HWMN1300439. However, it was still a whale I managed to cite. It was recognized in Happy Whale, and it did not yet have a name. And that was something I could fix. Back to you, voiceover Matt.
Here is my whale. You can see, since I saw it down here in the Antarctica Peninsula, actually if I zoom out you can see the rest of Antarctica, which is, a lot skinnier and more repetitive than I remember it being. Ha ha ha. Projection joke. Okay, anyway, it was spotted up here in Chile. That's pretty exciting. You can see the people who saw it down there and the pictures they took. And actually, where's my picture? It's in this group here. No, that's not my picture. That's me. That's mine. There it is. Oh, and these people saw it too. Hilda and V. Who are these people? Hilda and V. I guess they were on the Hurtigruten ship. Same with me. I mean, it was a fun ship, and there was a lot of people on there, but I didn't realize anyone else claimed it. But it's my picture. Let's have a look. Is it just my photo, or do they get a photo too? No, just me. Oh, they just said they saw it. Oh, come on, those freeloaders. But more importantly, hasn't been named yet, right? So it's swimming around. It's still called unnamed, or HWMN1300439. However, if you have a look up here, you can name your whale, right? If you donate money to a whale or ocean charity, you can then name the whale. And so I'm going to name it Krill Bill. Krill Bill. If you think you've got a better and or funnier whale name, Find your own whale, get to Antarctica and work it out for yourself.
Wow, I really am in the middle of nowhere here, and as that fog rolls in, I could be anywhere, much like this video sponsor, privateinternetaccess.com/standupmaths, means that your computer or phone or any device could be anywhere.
And private internet access is really useful when traveling. I can open the app on my phone, I can go through the list of where all the servers are, I can connect to them. Look at all these countries. I would then pick one in the UK, so here we go, let's go to London, and then it just connects. And now all the traffic from my phone is going via London. I can carry on doing business as if I was at home, and I'm only paying $2.11 a month to connect to any country I want, and as a bonus, hypothetically bypass any content restrictions on a Wi-Fi network in an emergency.
So you know the video about how there's no equation to plot a triangle? I was actually finishing that while I was in Antarctica, and I had Matam, my plotting software, running on my machine at home, and I don't want to go into the details, but because we do have onboard Wi-Fi in Antarctica, it's ridiculous, I was able to finish the video remotely because the onboard Wi-Fi here had no idea what I was doing online, what websites I was visiting, what may or may not be blocked. I was able to finish my video and it went out on YouTube. So huge thanks to this video sponsor, privateinternetaccess.com/standupmaths.
Hold up, rewind. Did you spot that in the background? That was a whale. I didn't even realize there's one behind me when I was filming that. Antarctica is amazing. If you can get there, you must go. There's just incredible wildlife everywhere, and I had a lot of fun. I mean, I'm not a biologist, but I really enjoyed spotting it. In fact, as you saw, I think I got so good at spotting wildlife, I may have actually earned a legit biology degree.
Wow, the poster's here. I did get a legit biology degree. Check that out. And it wasn't even on purpose.